Hi, my name is Bern Grush. I'm the Chief Scientist at Skymeter Corporation. Today I want to talk to you about financial grade GPS for road tolling. These are the kinds of systems that we're expecting to use to replace fuel tax in the future. What's key to this technology is that what we want to do is what's called time, distance, and place, or TDP road tolling. That consists of three important elements. First of all, we'd like drivers to pay less when they drive at off-peak times. This encourages them to drive away from peak hours. We'd like them to pay for distance instead of fuel. And we'd like them to pay differently depending on where they drive. So they may pay a little bit differently if they're, may pay less if they're driving away from the city instead of into the city. What this does is this maximizes fairness, both in terms of use of the road and also in terms of congestion when drivers are using the road. It also maximizes the utility of existing infrastructure by having drivers drive at slightly different times. What we also want to make sure we can do with a system that replaces fuel tax is that we can handle all roads with one billing system, as we do now with fuel tax. So we want to be able to handle all networks, no matter what it is, and all forms of road operators, whether they're provincial or state or municipal or county or national. We also want to have it all done with one single device in the vehicle, one transponder. We want to handle it all with one bill. And it also doesn't matter to us what kind of a tolling system or what kind of a tolling regime we want to use. In other words, some countries or jurisdictions use segments or area charges or a cordon charge, as is done in London, or also the handling of bridge tolls and tunnel tolls. It's also possible to handle parking and pay-as-you-drive insurance, again, all with the same device and all in a single bill. How this is done is the GPS satellites, and in the future the Galileo satellites as well, are intercepted by a device that's on the vehicle. This device is secure, it's on board the vehicle, and it's simply collecting trip logs. In other words, it's collecting information about the trips that the vehicle is taking. So again, the vehicle has a device on vehicle, collecting the signals. At the end of each trip, those signals go through a cell phone communication or any kind of communication actually, and goes into a central service which adjusts the price, sets the price for that trip. And this is also managed privately, because what's happening is the location information is staying in the vehicle and the billing information is coming out to tolling operators, to parking authorities, insurance companies, and so forth. So basically, the signals from the satellite are turned into billing feeds, which then become a bill for the driver. One way to think about this is, if you appreciate how a cell phone works, a cell phone which carries voice and you carry in your pocket or purse generally has a contract, is distributed through a retail outlet. There's service packages and monthly packages, monthly fees, and customer service and so on, roaming of course. This is exactly the same thing that happens with mobility meters. Instead of it carrying voice, it's just carrying road metering data, and instead of being in your pocket or purse, it's on your windshield of your vehicle. Otherwise it's the same. You would still get your device in the same way that you would get a cell phone, and you would have a similar service relationship as you do with your cell phone now. Now, one of the most important things about financial grade GPS, because we're actually using GPS to set a fee, is that it be very accurate, that it be very dependable, that it be very consistent. What this is we made a test with several vehicles and several routes through Seoul, Korea. Cisco managed this trial. And what we did was we went around several routes 40 times each. And each time around the route, we estimated what the cost of that trip would be. We used two kinds of GPS. We used the normal navigation grade GPS, and we used Skymeter's financial grade GPS. And what this shows is that the normal navigation grade GPS has a large degree of variation. In other words, each time it ran around, it gave a slightly different fee for the trip. And in the worst case, it was different by 15%. In other words, 15% over what it should have been. So in general, this kind of GPS is very noisy, very variable, and it can overcharge. The financial grade GPS has far less variability. There's two stages to that work that we do. The yellow is the processing that occurs inside that onboard unit, and the blue is another layer of processing which adjusts the price yet further. And what you'll see is that we're not overcharging. There's very, very little variability. It's highly consistent. So in other words, what financial grade means is that it's consistent, that we can rely on it to set a fee, and that we can use this in the event that we need to show for certain that we've charged the right price for the trip. Now the devices themselves that we have happen to be self-installable. They're completely autonomous. They don't connect to the vehicle except to be attached to the windshield. They are broken on removal intentionally so that you don't move them from vehicle to vehicle, or you can't get one that's on the wrong kind of vehicle, because you can appreciate vehicle charges for a large vehicle like a truck, for example, will be different from that from a car. So that is guarded against as well. It's also possible for the vehicle owner to have private access to the data to check where their trips were and to satisfy themselves that they're paying the right amount for the right roads and so forth. It's also possible to set the system up that the motorist can delete the data after use for further privacy that the motorist may wish to have. Now enforcement for these is twofold. First of all, the unit itself in the vehicle is sealed, so it can't be tampered with. If it is removed from the screen, or if it's tampered in some way, and by this I mean if it's jammed or shielded and otherwise there's gaps in the data, that will be noticed by the OBU and it's self-reported back to that central system that does the pricing. So we are designed it to be very, very hard to tamper. Now, it may be the case that some of them fail, or that some vehicles don't have one. How that's handled is through mobile cameras, either handheld or fixed. They can be even mounted on other vehicles, for example. And what we're looking for in this case is vehicles without a meter or with a broken meter. But if with meters not broken, it's self-enforcing. So it saves quite a large sum of money for the operators of such toll roads as this. So that's a little sense of what financial grade GPS for road tolling can do. I want to point out very importantly that this same device that handles road tolling as I've described also handles parking by a minute. It requires no enforcement of parking, because if a car stays over the allotted time, the fee can be raised, for example, so you don't need to put tickets on cars. Pay-as-you-go insurance is a far fairer way to pay for insurance. Those who drive more, pay more, drive less, pay less. It actually encourages less driving, which is a very valuable element of pay-as-you-drive insurance as well. Lastly, we can also do carbon metering. There's a value of metering fleets for carbon footprint, output, and so on, so that this same device really handles a large range of payment as you go and metering as you go very accurately and very consistently with our vehicles. So thank you.